Hi, in this video I'm going to teach you integers, round off and basic numbers. We are going to deal with base 2 number. Our last video we introduced integers. I'll show you how we can add, subtract integers. Integers are positive and negative whole numbers. Let me show you how you can add and subtract, multiply and divide integers. Let's take plus 4 plus 2. These are different terms. This is addition. Plus 4 plus 2, we have plus 6. Plus 4 plus minus 2, we have plus 2. Minus 4 plus 2, we have minus 2. Minus 4 plus minus 2, we have minus 6. A minus sign and a minus sign, you add together, will give you a bigger minus sign. A plus sign and a plus sign, you add together, you have a bigger plus sign. When you have a minus sign bigger than a plus sign, your answer reduces. You have a minus answer. When you have a smaller minus sign and a bigger positive sign, when you add together, your answer is positive. Now we can say big plus small plus, we are having big plus. A big positive plus a small positive will give us a big positive. Here we discover that is a big positive plus a small negative is giving us a positive. A big minus and positive give us a minus. So we say big minus plus small positive will give us minus. Here we have a big minus plus a small minus. We have big negative plus small negative is giving us a big negative. Subtraction. We take plus 4 minus plus 2. We have plus 2. Plus 4 minus 2, we have plus 4 minus 2, we have plus 6. Minus 4 minus plus 2, minus 4 minus plus 2, we are subtracting minus from a positive, and the minus here is bigger and the positive here is small. So what do we have? When we have minus this, it becomes minus 6. Minus 4 minus 2. These two minus sign become plus, and we have minus 4 plus 2. Our answer becomes minus 2. Where we have two minus sign together, the sign turn to a positive sign. The same thing is applicable in the second example here. Minus and minus become plus, and we have here positive 6. So when we add together, this is what we have. In our summary, we will say big positive minus small positive is going to give us positive. We have big positive minus small negative is going to give us positive. We have big negative minus small positive is going to give us negative. Here we have big negative minus small negative. We have a negative. That's a summary of subtraction. 4 positive times positive 2. We have positive 8. Plus 4 times minus 2. We have minus 8. Minus 4 times plus 2. We have minus 8. Minus 4 times minus 2. We have plus 8. We are going to look at the summary of this also. In summary, we discover that big positive times small positive will give us positive result. Big positive times small negative is going to give us a negative result. Big negative multiplied by small positive is going to give us a negative. And big negative multiplied by small negative is going to give us positive. Where we have positive and positive multiplying themselves, the result is positive. And when we have negative multiplied by negative, we still have positive. Whenever there is a negative sign and a positive sign multiplying themselves, the negative sign overwhelms the positive sign. The answer is a negative sign. Where negative is multiplying by positive, the answer is negative. When we have positive and positive, the answer is positive. And when we have a negative multiplied by a negative, we have a positive answer. Division. 4 positive divided by plus 2. Our answer here is 2 positive. Plus 4 divided by minus 2. Our answer here is negative 2. When we have negative 4 divided by plus 2, our answer here is negative 2. When we have minus 4 divided by minus 2, our answer here is plus 2. In summary, we'll have here a big positive divided by small positive. We have positive. Here we have a big positive divided by a small negative. Our answer is negative. Here we have a big negative divided by small positive. Our answer is negative. And when we divide a big negative divided by a small negative, we have a positive. Why do we have positive here when we are dividing by negative? It's simple. If you have 4 divided by 2, your answer is 2. If you have minus 4 divided by minus 2, in this case you discover that this minus cancels this minus, and you are left with 4 over 2, which is 2. That's how we got this positive here. This minus have cancelled this minus. That's how we got 2 here. In this second example here, we have plus 4 divided by minus 2. we now discover that our answer is minus 2. Why do we have minus 2? The minus overwhelm the positive. The same thing is applicable in a situation where we have minus 4 divided by 2. This is plus 2. If minus overwhelm the positive. When positive is divided by minus, we are having a minus. When negative is divided by positive, we have a minus. What is standard form? When do we say a figure is in a standard form? A number is said to be in a standard form when that number is multiplied by the power of 10 and the first numbers are between 0 and 10. What do I mean by that? If we have 3.5 times 10 to the third, this number is multiplied by the power of 10 and this first number here is not more than 10 and it's not less than 0. It's not more than 10 and it's not less than 0. If we have 0.02 times 10 to the fifth, it's in standard form because 0.2 is bigger than 0. 0.2 is bigger than 0. So it must be between 0 and 10. It must be between 0 and 10. If you have something like 11.34 times 10 to the 6, this is not in the standard form because 11 is bigger than 10. You only bring this one forward and we have 1.134 times 10 to the 7. As this one is increasing to the left, this one is increasing. So this one is in standard form, whereas this one is not in standard form. So a number is said to be in standard form when it's multiplied by the power of 10 and that number falls between 0 and 10. A number is said to be in the standard form when that number is multiplied by the power of 10 and the first number is between 0 and 10. Numbers, digits like 1, 2, 3, 4 are always rounded down and digits like 6, 7, 8, 9 are rounded up. When rounding of numbers, digits like 1, 2, 3, 4 are always rounded down and digits like 5, 6, 7, 8 and 9 are always rounded up. Let's see some examples. If we have numbers like 3, 4, 2, 5, we can round off this number to 3 significant figures. When we talk of 3 significant figures, this 5 that is at the end, we round it up because it's fall between 5, 6, 7 and 9. So this number to 3 significant figures will give us something like 3, 4, 3. If we have 3, 4, 2, 5, we can round off this number to 3 significant figures this way. We can see I fix a 0 here. We are rounding off the number. So we change this one to 10 and add it here, it becomes 343, and this one becomes 0 because we have rounded up these to 10. And we can bring this one to the nearest 100. To convert this to the nearest 100, we have something like this: 3400. This is the nearest 100. We bring this one to the, this is 400. 25 is not up to 50. We have converted this to 5. This one is not up to. That's why we have 3400. Let's do example 2. We have a number like 7.283. We can convert this number to 2 decimal places and also convert to 1 decimal place or to the nearest whole number. If we have to convert 7.283 to 2 decimal places, this is what we have. We round down this. It's not up to 5. We round it down. Then if we want to convert it to 1 decimal place, we'll have to 1 decimal place, we'll have 7.3. Why are we having 3 here? We discovered that 8 is bigger than 5. It's bigger than 4. 8 falls between these numbers. And when we have 5, 6, 7, and 8, we round them up. When we have 1, 2, 3, and 4, we round them down. So rounding 8 up, it turns to 1. We take the 1 and add to these 2, we have 7.3. If we convert this, we round 1, round the 8 to 1, add it to this 2, we have 3. So that's how we can convert it. Now, to convert to the nearest whole number, 7.283 to the nearest whole number. We discover that 2 is not up to 5. We round it down. Even after converting this one to bring this one to 3, and when the one becomes 3, it's not still up to 5. So we round it down. Rounding it down, we have 7.0 or 7 as the nearest whole number. When working with 4-figure table, it is wise to round off numbers to 3 decimal places. When working with 4-figure table, it is wise to round off numbers to 3 decimal places. Number basis. Number basis. The most common number base we have is the base 2. Let's find how we can convert binary numbers to binary numbers to base 10 numbers. Let's see how we can convert from base 2 to base 10 and possibly from base 10 to base 2. Binary numbers. Binary numbers are base 2 numbers. Base 2 numbers are made up of 1 and 0. Binary numbers use a base 2 place value system. We have 1, 0, 1, 1. 2 is not written in the numbers because 2 act as a base. Another example of a binary number is 1 0 1 1 0 1 2. This is another binary number made of 1 and zeros. So let's see how we can convert this number to base 10. Then later we will see how we can convert from base 10 to binary numbers. Now, example 1. We have 1 0 1 2 1 0 1 0 1 1 base 2. Let's convert this to base 10. When you want to convert to base 10, what you do first is count the number from right to left and put in the powers, counting from 0 to the highest power of the figure, the place value. Now we have 1 0 1 0 1 1. Put 0 here, or put 1 here, you put 2 here, put 3 here, 4 here, 5. Now you expand by multiplying by base 2. So this one will be something like this: 1 times 2 to the 5th power plus 0 times 2 to the 4th power. Put the 4 there, plus you use this now: 1 times 2 to the 3rd power plus 0 times 2 to the 2nd power plus 1 times 2 plus 1 times 2 to the 0th power. That's how you arrange it. Now you sum all this or simplify this before you can have this base 2 number equivalent to base 10 number. Now 1 times 2 to the 5th power. How do we get this? It's multiplying 2 to the 5th power. It's multiplying 2 times 2 times 2 times 2 5 times. And when we multiply 2 times 2 times 2 by 5 times, we have 2 times 2 will be 4. 4 times 2 is 8. 8 times 2 is 16. And 16 times 2 is 32. Now we have here 1 times 32 plus, find out this 2 to the 4th power is also multiplying 2 4th times. We have 2 times 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So we have 0 times 16. We add also. This one is to the 3rd power. 2 times 2 times 2. Now 2 times 2 is 4. 4 times 2 is 8. So to the 3rd power we have 1 times 8 plus 2 times 2 is 4. 0 times 4. 2 times 1 is 2. So we have plus 1 times 2. And 2 to the 0 power, anything raised to the 0 power is 1. Anything raised to the 0 power is 1. So let's continue here. 1 times 32 is 32 plus 0 times 16 is 0. Anything multiplied by 0 is 0. 1 times 8 is 8. 0 times 4 is 0. 1 times 2 is 2. And 1 times 1 is 1. So we add 32 plus 0 is 32. 32 plus 8 is 40. 40 plus 0 is 40. 40 plus 2 is 42. And 42 plus 1 is 43. So 101011 base 2 is equivalent to 43 base 10. That's one example of converting binary numbers to base 10. Example 2. Let's convert 100011 01. As I said earlier, you count from here and put your power. This is base 2. You count from here. 0, 1, 2, 3, 4, 5, 6, and 7. You expand it by multiplying by 2. We have here 1 times 2 to the 7th power plus 0 times 2 to the 6th power plus 0 times 2 to the 5th power plus 0 times 2 to the 4th power plus 1 times 2 to the 3rd power plus 1 times 2 square plus 0 times 2, 1, plus 1 times 2 to the 0. Now we multiply 2 7 times to have 2 to the 7th power. So let's multiply together. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. 64 times 2 should be 128. 1 times 128 plus this, the 6th time. We multiply 2 to the 6th time. We have 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2 is 32. 32 times 2 is 64. So we have 0 times 64 plus 0 times 32 to the 5th power is 32 plus 0 times 16 plus 1 times 8 plus 1 times 4 plus 0 times 2 plus 1 times 1. Remember, anything raised to the 0 power is 1, and anything raised to the first 1 power is itself. That's why I multiply this 0 times 2, because this 2 raised to the first power is still 2, and 2 raised to the second power is 4. 2 times 2. 2 to the third power is 8. Now let's summarize or simplify. We have 1 times 128 is 128 plus 0 times 64 is 0. Anything multiplied by 0 is 0. 0 times 32 is 0. 0 times 16 is 0. 1 times 8 is 8. 1 times 4 is 4. 0 times 2 is 0. 1 times 1 is 1. So let's add together. 128 plus 8. 8 plus 8 is 16, and you have 1 you have carried. That's 6. You have carried 1. You add the 1 here, you have 3. You add this 1 here, you have here 1, 3, 6 plus 4 plus 1. 1 plus 4 is 5. You have your 5 here, and you have your 1, 3, 6 here plus 5. 5 plus 6 is 11. You write your 1 and carry 1. Carry the 1 and add here, you have 4. And you add this other one here. So when you convert 10001101 base 2 to base 10, you have 141 base 10. Let's convert from base 10 to base 2. Let's convert from base 10 to base 2. Converting from base 10 to base 2. Example 1. If we are given a number, say 43 base 10, and we are asked to convert it to base 2, what we do here, we do continuous division by 2 and put down the remainder. At the end of our division, where we discover that there is nothing for us to divide any longer, we take the remainder from the bottom up. Now let's do it together. 43. Let's divide. Continuous division. We divide by 2. 4 divided by 2 is 2. 3 divided by 2, 1. Remainder 1. We divide by 2 again. 2 divided by 2 is 1. 0. Remainder 1. 2 times 10 is 20. And we have 21 here. 1 will remain. 2 times 21 is 42, and 1 will remain. So that's why we are having 1 here. We divide again by 2. 10 divided by 2 is 5. Remainder 1, 0. We divide again by 2. 5 divided by 2, we have 2. Remainder what? 1. We write a 2 here. 2 divided by 2 is 1. Remainder what? 0. We draw a line here. Continue to divide. 1 divided by 2 is 0. Remainder what? Remainder 1. I was saying that when you keep on dividing, you come a stage where you don't have anything to divide here. You write the remainder from the bottom. So our answer here will be, from the bottom we have 1, this 1, 0, 1, 0, 1, and 1. This is base 2. 43, when you convert it to base 2, you are going to have 1 0 1 0 1 1. How do we get it? When we continually divide 43 by 2 and write down the remainder, we take the remainder from the bottom, align it horizontally, and we get the answer 1 0 1 0 1 1. You arrange from the bottom. Arrange from the bottom. That's the answer. Let's take one more example. Convert 54 to base 2. Now we have 54 here. We have to divide with 2 continuously. 5 divided by 2 is 2. By 14 is 7. Remember what? 0. Because we know that 2 times 27 is 54. Now we divide by 2. 2 divided by 27 is 13. Remember 1. 13 divided by 2. We have 6. Remember 1. 6 divided by 2. 3. Remember 0. 3 divided by 2. 1. Remember 1. We put our 2 again. 1 divided by 2 is 0. Remember 1. Similar step we did. We divide continuously until we discover that there is nothing to divide down here. Then we take our answer from the bottom and rise up. Now 54 base 10 is equivalent to 1 1 0 1 1 0 base 2. We take the answer from the unit and write it in a horizontal form. Our answer is 1 1 0 1 1 0. This is equivalent to 54 base 10. We have come to the end of our lesson today.